Okay, let's start. Good morning, good evening, or wherever you are joining from, and welcome to Data Driven Community Virtual User Group meeting. A few words about the Data Driven Community. If you will check the community website, then you will notice we are managing two branches of activities here. Scroll down to the page a bit to see the upcoming events. On the left side of the page, you can notice the Future Data Driven Summit, an annual conference we are leading and running with multiple data platform user group partners. The second branch, sorry,
to cut you.
go ahead.
Announcement. The website show 2024 because it's an old screenshot. We are working on the future data driven 2025. That's a small note.
Yes, we already started planning for 2025. So stay tuned, and if you go to this website, you'll find all the details. Look out for the more information coming up soon. We'll be also sharing on the social media. So the second branch of the activity are weekly meetings, like you are in right now, the Cloud Data Driven User Group. And also, you are more than welcome to contact any of the community board. Joseph is the founder and the co-administrator. Ronen is the second co-administrator. Anna Bikes is the third moderator. And this is me. My name is Deepthi Gopuri. I'm a database administrator and also a Microsoft Data Platform MVP. I'm a third co-admin of the data-driven community, and I will be hosting this session today. Together, we are here to help and serve the data platform community. During the meeting today, please feel free to use the chat for any questions and discussions as well. You are more than welcome to use the reactions. It doesn't interfere with the course of the meeting. And if you hear something you love, like, or you want to clap hands, then feel free to do so. So today we are honored to have Dejan Sarka with us. Dejan Sarka is a MCT, Microsoft Certified Trainer, and also SQL Server, Microsoft Most Valuable Professional, and like mentioned there. He's also an independent trainer and consultant that focuses on development of databases and business intelligent applications. Dejan, you can go ahead and share your screen and share a few words about yourself.
Thank you very much. So let me share my screen and officially start the presentation, where I will also introduce more, say a few words more about myself. So what I'm going to talk today about is setting up a testing environment in advance, not just solving problems when problems arrive. And as Deepthi said, I'm Dejan Sarka. I am pretty long in this business, altogether nearly 40 years. And I'm dealing with SQL Server from 1992, also 33 years from version 4.2 and so on. And I co-authored already 20 books about SQL Server. I also deal a lot with data science. I'm a statistician, so I also authored a couple of more mathematically oriented books. And what I will use my this infrastructure, I will use it in demo to discuss some decisions that are typically not frequently made decisions about databases, and people do not really have idea what is the impact of these decisions. So, of course, the infrastructure can be used to measure anything you wish, and you can also expand it. It's using basically whatever you have in SQL Server, from dynamic management views to extended events and simple measuring time by checking the clock, right? But I decided to use it on some seldomly used optimization options. So we know that we have row and page compression in SQL Server, but we don't know what is the impact of this compression. Of course, you can imagine that before updating data, you have to decompress it, so probably there is some impact on CPU, but on the other hand, maybe less disk I/O and so on. So let's see what is the actual impact. Can we afford to use it or not? And then I will also use the same infrastructure to measure the impact of globally unique identifiers, or GUIDs. GUIDs are pretty frequently used, popular among developers. Are they also very good for databases, or do they have some drawbacks? And then I will show some other things. DML after triggers, we know that we should be careful with them. Transactions are longer, there is more locking. So how much more locking? And what about output clause? We have output clause from SQL Server 2005, or maybe from 2016 we have temporal or system version tables. We could use, for example, DML triggers, output clause, or system version tables to store all of the changes into archive tables. And we'll check which of these options is the most efficient in terms of CPU consumption, reads, writes, locks, and so on. So let me start with data compression. Basically, variable length data types are always some kind of data compression, and this was in SQL Server from at least 4.2. In SQL 2005, we also got decimal type that could be stored with variable length. But serious compression came with SQL 2008. Row compression simply means that all fixed width data type values are stored in variable format. Also integers, also character and char columns, binary columns, not just n var char, n char, and binary, var binary, and so on. Of course, if all of the columns are already using variable length data types, then row compression cannot help a lot. And then we have page compression, which I will explain in a minute. With SQL 2008 R2 in year 2010, we also got Unicode compression, and from 2012, but I will not go there since this is a completely different topic. We also have columnar storage, which has also incredibly good compression. So let's see about update overhead. Maybe we can use some of these compressions also in transactional processing scenarios. So how does page compression work? We have a page with this kind of strings. I have 3 columns, 3 rows, and I have page header. And in page header, when we use page compression, SQL Server stores additional dictionary. So we have what is called prefix, also sometimes called value compression, and we have dictionary compression. Prefix compression is kind of the same thing as dictionary compression. So we are storing substrings in a header, and then in actual columns, we are storing only the number of characters we use from this dictionary, from appropriate column, and what is left. So why do we have then 2 different names, prefix and dictionary, since prefix is also kind of dictionary? Dictionary compression is working on any kind of substrings. So it works on character and binary data only. Prefix is, if we talk about character or binary data, it means we are using substrings from the beginning of the strings, right? But the difference to dictionary compression is that we can use this prefix compression also on dates and integers. Now imagine that we have integers like 1000, 1001, 1002, and so on stored in our page. So we can store prefix 1000 and then only small values 0, 1, 2 in the actual rows. That's why we have 2 compressions. Unicode compression works on Unicode data types only, so it is very cheap. So SQL Server turns it on automatically as soon as we turn on row or page compression. From 2008 release 2, we automatically got Unicode compression. It means that we are storing also this Unicode data type values in variable format using as few bytes as possible. So, English, German, all characters fit in the single byte. So we can get up to 50% additional compression on Unicode data types. In Japanese, we use more bytes for a single character. So typically you get only 15% of compression. And since this is very low performance penalty, it is turned on automatically. What I'm trying also to say here is that performance penalty for Unicode compression was already measured by Microsoft, so they cannot measure it since since it's now automatic, and Microsoft realized that it is extremely low impact. So as I said, it turns on automatically as soon as you use row or page compression. So what is this overhead? I will create something like this. I will measure physical writes using /sysdm-io virtual file stats dynamic management function. For reads, I will use logical reads since I hope that most of the reads will be from the cache. So I will use /sysdm-exec sessions. I could use also /sysdm-io virtual file stats for physical reads. CPU time, I will get it from /sysdm-exec query stats. Elapsed time, I will just measure difference between two sysdate times. And logs, I have to use logs for DB extended event counter. And then I will read this counter. I will start an extended event session, and then I will read the value of this counter before some modifications of data and after modifications of data with /sysdm-exe sessions and /sysdm-exe session targets dynamic management view. Let me not show this yet. Let me go now to demos. There is a lot of code here. I will not run all of the demos since it will be simply too long, but I will start running it, and then I will switch to results, and you will get the idea how you can run these demos, or how you can even replace the code with your own code you want to test, maybe some queries you want to test in advance before you use them in production, or maybe even some the tables, additional design, and maybe some, I don't know, views, indexes. What happens if you introduce them in production? What is then with logs, reads, writes? I will create additional internet sales table, and I will insert data. I'm using here AdventureWorks DW 2019 demo database, so I will insert from the original fact internet sales table data, but also I will add some data from customers and products table, like customer name and product name. And let me start by also checking index fragmentation. This could be also useful, but this is more like static information. So I'm using sys indexes, sysdm-db index physical stats to get the present fragmentation. So logical fragmentation, how many times are physical extents out of logical order. So this is has very huge impact on ordered scans. So after the creation, physical order is practically the same as logical, so fragmentation is very low. Let's check the space used by this table, and you see it is 10 megabytes, so 10,376 kilobytes. So let's use row compression and let's check the space used. Now these are still simple demos. We already see that reserved space it's not always the same as I write in comments, but it's already like half less than original table. Now let's check with page compression, and we have like little bit more, or no, it's 1/4 of the original size. Let's go back to no compression and check again, and we usually get slightly different result than originally, so it's not completely reversible process. So you see, I will just recreate the table to start from the scratch and have the original size. Okay, now what can happen before I implement any of the change on this table? So let's say that I'm having regular transactional processing application. So we know we can insert data, update data, delete data, and select data. So I will mimic all of these actions. I will store 1/5 of the rows, like internet sales key modulo 5 equals 0. So every 5th row in an additional table, I will use this row to select rows for delete and later for insert. I will also make the best index for those actions, and then another 1/5 of the rows for update, right? And create another clustered index on this table. And then I will create tables to store the result. So I have, okay, this result is just ID, table name, operation type, compression type, and this is just measuring time in milliseconds. So this is measuring for every single operation: delete, update, insert, select. And the summary table, which will store data from dynamic management objects and extended events: start CPU time, end CPU time, start reads, end reads, start logical reads, physical writes, logs. And then I will simply calculate them, those values, summary values for CPU time, reads, writes, and logs with computed column. And I have my two tables. Now I have to create extended event for my database. Unfortunately, when you create extended event session, when you add an event, log acquired, you have to use constant database ID. That's why I checked it in advance. You cannot use DBID function here. Anyway, I already created this event, so I should get an error here, right? And then I will warn the cache. So all of the data is in the cache. So I have always the same starting position. Now I already created procedures to make code more readable. So I have created these procedures for select sales. And I am actually doing always this selects, inserts, updates, and deletes in two ways, row by row with a cursor, and multi-row, you see, with a partial scan. And then I delete rows. Remember, I have additional table for deleting. And again, I'm testing here with single row deletes only, since we are mimicking transactional application, and also update, I'm mimicking single row update only, and also insert. So I'm mimicking also single row insert. So when the cache is warned, I can start the session, and then I start things. I write down starting values. But before that, there is an important, not not here yet. Okay, not here yet. There is an important, I missed probably an important comment. There is somewhere in this file, it doesn't really matter. What does the comment say? The comment say that you should discard the results of the select. Otherwise, you will get the results back to the client, and this will use the most CPU. So in a grid, I will just say discard results after execution. Also for text, discard results after query execution. So we are working on server only. I don't want to see the results of select in my management studio. So let's also write the starting values. And of course, you see, let me execute this, and then I will show the code. Let me start executing the code. Delete orders, customers. Okay. Ooh, I'm using the wrong file. I went to the wrong file. Let me stop the session. That's why I went to the wrong file. That's why I missed the comment. And let me go here. I clicked to the wrong session. So let me go here and discard the results for grid and text. Okay, and restart the event session. And write the values here. My procedures are created, so now I will just execute those procedures with parameter what is compression type, and the procedures are writing down detailed information about elapsed time, and after all of these procedures will be done, I will do the summary statistics update. So I will read the end CPU, end reads, end writes, end logs. And as I told you, I'm using sysdmx query stats to get the total worker time or total CPU. And then I'm using DMX accessions for logical reads, DMIO virtual file stats for physical writes, and I'm using these extended events, dynamic management views for reading the number of logs. So this usually takes a little bit more than 1 minute, right? And you can already imagine that I cannot afford, now it's even slower because of Teams, that I cannot afford in this presentation to go through all of the code. So I'm just showing you this starting part and how does it work. And when this will be finished, I will just write down the end values and stop the session. Okay, it's even slower now. It's always like these teams actually use a lot of resources sharing the screen. So now it's already nearly 2 minutes. Usually this part, if I'm not using Teams, it's around 1 minute on my computer. Anyway, I already, of course, measured this till the end and have already interpreted the results in a Power BI report. I will not wait too long with this. It's really getting 2.5 minutes already. So let me just finish this, execute the ending session, and then go to query and query options and get the results back, otherwise I will not see anything from my table. So you see, here is what I wrote. So select was already there, trickle delete, trickle update, it was already waiting for the insert. And then this is like end results for compression type none, start CPU, end CPU, start writes, end writes, and logs. And then I can get the total CPU time, reads, writes, and logs for this session. After this is done, since I have done some modifications, I simply recreate the data, right? Recreate the data, and then I also rebuild data with row compression. And then I warm the cache again, measure with row compression, and so on. And I continue the same thing, recreate the data, and measure with page compression. Okay, warm the cache, start event session, do the updates, and so on. Okay, great. Now let's imagine that I have already executed all of the code up to here. So I have altogether 12 rows in the detailed results for elapsed time and 3 rows for different types of compression. So let me show you what are the results, and these are different measures. As we expected, without any compression, the CPU usage is quite lower than with a row and page, but there is not big difference between row and page. What about reads? Here the situation is the opposite. With non-compression, of course, we had to do more logical reads. Elapsed time, practically no difference, very, very low difference, not really a problem. And writes, practically the same. Compression didn't make any additional writes. What about logs? Also practically the same. So what does it mean? We only got this kind of serious differences in CPU time. But look at elapsed time, very, very low difference. Reads, of course, some advantage on compression. So basically, what does it mean if we try to interpret these measures? So the impact of row and page compression is really quite low. And if you have enough CPU power, maybe you can even use it in transactional applications. Impact is very, very low, right? And yes, I'm doing this in a single user mode because I wanted to limit the impact of other users. But you could also try what does it mean on a production server. Maybe you can even get some different results there because of a multi-user environment. You have some weights and then elapsed time goes up, right? But as I said, the important part here is infrastructure. But please note something. I will use zoom it here. I have filters on this page. Compression type is non, page, or row. Apparently, there is something more here. And what is this more? Let me go here for a moment to the slide. Now, compression. People are quite afraid of compression. People are not using it a lot since they say, okay, I will have some impact. But now, as I said, you can measure this impact. But on the other hand, people are very keen on using GUIDs. So what is the impact of GUIDs? So let's see what happens. And of course, I will not again execute all of the code. But let's see what happens, or maybe I will execute it in the background. What happens if I add unique identifier with default new ID to my table? Internet sales GUID, unique identifier with default new ID. And insert the data, right? Now, let's warm the cache. And you can imagine that I will definitely stop this because it will be really impossible to wait until this finishes. Look at this comment. Time much longer, so 25 times approximately longer, okay, with missing end parentheses. So I will not even measure this, but also after I do all of these updates and so on, what happens is also the fragmentation is very high, so I will not do this now. But if I would execute all of the updates, then this fragmentation would go up to like 75%. But let me go directly to results. It would be really impossible. You would now, since the computer is also slower because of Teams, have to wait probably for like 1 hour before this would be done. So let me add the impact of GUIDs here. Now look at this result, CPU time. Look at the results, GUID, like look at the number, 1,200,000 approximately milliseconds, while this page compression, it's really nearly impossible to click because it's so narrow. So it's practically zero. Sum of reads, wow, look at this. These numbers didn't change, but the number with GUID again, like, wow, I don't know how many times bigger. Elapsed time, we already know. Here, the difference is even the smallest, like 25 times more approximately. Writes, okay, GUIDs do not produce a lot of additional writes or just 1K additional writes. What about logs? Wow, look at the number of logs. Of course, many times SQL Server had to do range logs, multiple rows logs, and so on. So I hope that this is somehow a shock for you. I hope that you realize what do GUIDs do to the database. Now, after the modifications, the index fragmentation would be enormous. So what if I know you cannot have impact on every database you have? You got some databases with some applications. What if you have some GUIDs in some database? Probably, if it's not yet slow, it will be slow very soon. At least what you can do, you can rebuild indices every night maybe and help SQL Server this way. But compare impact of GUIDs to impact of compression. It's like in elapsed time difference is like 25 times, but all other things like CPU time, reads, logs, except writes, it's even worse. It's like, I don't know, 100 times more. Let's see details. Here in details, I have elapsed time for details for different operations. So we have like combo select means we have single row select and multi-row select, and then trickle delete, trickle insert, trickle update, single row. Look at the elapsed time with GUID. Like for example, trickle update, it's like nearly 100 times more than any other measure. Of course, select, yes, you can see that page and row compression speed up selects, but they slow down deletes, inserts, and updates. However, compared to none, it's really not big difference. Anyway, suddenly you realize that using GUIDs, it's really not appropriate for databases. So, as I said, infrastructure, you can also add additional counters, additional columns from dynamic management views. But as I said, you can create your own infrastructure. But then with these measures, you can get results you didn't expect. As I said, I've seen practically never I've seen using row or page compression, but I've seen using GUID so many times in my career. And people don't realize that impact of GUID is like from 25 to 100 times worse than impact of compression. Now think again if you are designing a new database, whether you want to use GUIDs or not. So this is really, really impressive. And this is why it is important to measure things. You know, I'm actually big fan of measuring, because in general, when you read books, read articles, or when you go to presentations, when people talk about optimizing and so on in SQL Server, you usually hear like, this is good, this is bad. Now, how good? What is better? How much better? How much worse? With measuring, you can get the real ideas, what is important for your database, and you don't also spend too much time on optimizing there where you can get, let's say, I don't know, 3% improvement. Basically, also just a general advice. If you want to speed up things, let's say, for 100%, for 2 times, right? Then simply buy or rent, if you go into the cloud, better hardware. It's so simple. Don't spend time on big optimization. If you start spending time and effort on this and even hire an external consulting, then your goal must be 10 times or 100 times improvements in some areas. But now, when you can measure things with this infrastructure, you can even check in advance what would be the impact of a specific decision. I also will use the same infrastructure again, and also I will just show you the code and then comment for following the changes or auditing the changes in your database. Traditional method was with after triggers. And here we have again this general advice. You know, triggers are part of transactions. They make transactions longer, so locks are held for a longer time. You have more wait locks, and then with more wait locks, you will have more probability for deadlocks, and so on. But again, all of this is true, but it doesn't tell you how bad triggers are. We can, inside the DML trigger, I will use just after trigger, we can use inserted and deleted tables to audit the changes. To store with deleted internal table, we will get rows before modification, insert after modification. So if you use update statement, both tables are full. If you use insert statement, only inserted is full because there was no previous state. If you use delete statement, then only deleted is full. When you program the trigger, you should follow some good practices. Make sure the trigger works not just for one row, that also works for multiple rows. And of course, yes, we know these general rules. Also, if you have many triggers, you cannot specify the order of how they fire of all of them. You should program them to be independent of other triggers. You can only specify the first and the last one to fire, so you can control the order if you have up to 3 triggers per action. Now, with SQL 2005, we got the output clause. So this is additional clause in insert, update, delete statements, and also exists for merge statement. And it's kind of, let's say, automatic trigger, let's say. So after insert, you have inserted table. After delete, you have deleted. After update, you have both tables. Please note that this is somehow different than in triggers. In triggers, both tables exist for every statement. It's just that inserted is empty for delete action, deleted is empty for insert action. Here in output clause, if it's insert statement, you can use only inserted table. If you use deleted table in the output clause, you get an error. After delete statement, only deleted table is available. For the merge statement, you have also additional column $action or a function $action to see which action triggered the rows in the output. You can use output to send rows directly to the client or output into to save the changed data. Now, like intuitively, at least I thought that output clause should be somehow more efficient than triggers, since this is part of the DML statement. This is part of the insert, update, delete statement. So it would be nice to check and compare the performance impact of output clause and to compare with triggers to finally get the idea right. Is it faster? How much is it faster? Or maybe it's not faster or better than triggers. And then with 2016, we got this automatically system versioned tables, so-called temporal tables. We must change the structure of tables. Please note that for triggers and output clause, we don't have to change the structure of tables. We must add two datetime, two columns, and then we must add these columns must be connected into a period, and then we must create a history or archive table and connect this table with alter table to the table where we want to follow the modification. If we use automatically created history table, then it's a row storage with clustered index on this period columns and page compression, if I remember correctly. It's not written on the slide, but I think it's page compression. If you create it manually, then of course you can define any kind of storage, also additional indexes. And then querying temporal tables, we get additional clause in the from part of a query for system time. And then we can use sub clauses like as of, give me state on that date time, from to, between also includes borders, containing begin time, end time gives me all of the changes in specific time, or all to return everything. Basically, this for system time clause is just a shortcut making query simpler. You can always write the full query manually, so you have to browse two tables, current and archival or history table, and use union all to union the results, and then properly filter data with where clauses. So how do these temporal tables work? If you delete a row, it goes automatically to the history table, and the this period end date time is closed. If you insert the row, then it goes to the current table only, of course, and the starting time is the current date time. And ending time is maximal date time too. So year 9999, December 31st, and so on. When you update the row, the validity period end time is changed to the time of update. Old version goes to the history table, and new version remains in the current table with start time of the update, and end time unlimited, means this is current version. This is how it works. So this is another way how to follow the changes, and it could be interesting to compare these three options. So before I compare them from performance point of view, let's repeat again, what does it mean for changing the database, but also for changing the code? So for DML after triggers, you must have permission to alter tables, but you do not really alter tables. You are just adding triggers to these tables. Application doesn't need to be changed at all. For temporal tables, you have to alter the tables. You have to add this data to columns, create history table, connect with alter table, current and history table. But you don't need to change anything in application. What if your application is using select star? This is ugly written, poorly written application. Still, you don't need to make any changes because you can create these two date type, two columns with additional attribute hidden, which means they are hidden from select star. You can always retrieve them by using their names in the query. Now, what about output clause? No change on the database, but full change on your code. So it means every insert, update, delete that you want to archive must be, or to audit, must be changed to include the output clause. So let me go to the demos, and I will go through demos now really just theoretically, since I don't know even where exactly I am after wrongly doing some changes here. So here I am actually doing this in a slightly different way. So I'm creating two tables. I will create these tables. I'm using this scenario customers and orders, and I have also foreign keys. So everything to mimic as much the actual production environment as possible. And I'm actually giving quite a lot of rows in this, inserting quite a lot of rows in these two tables. So first customer table. Oh, and I should, for this query, also, if I remember, yes, do not discard the results. Okay, I will just use count quickly. I don't need too many. So I have nearly 1 million rows in orders, and I have customers for these orders. So it's 90,000 customers for these orders. Okay, and then, okay, again, I create copy of data. So after each measurement, I can get the old data, and then I create additional two tables for delete and insert, and orders and customers. So first delete and later insert, and also rows for updating. Okay, and I also create all appropriate indexes, all indexes that I need for this table. And then I start measuring things, so DML performance with nothing. So no triggers, no output clause, nothing. But what do I measure? Let me open another file. So I am creating now procedures. I measure more things. Since I'm only interested on changes in data, I will not measure selects. I'm not interested in selects. So I will measure inserts, updates, deletes. So 3 actions, but in 2 tables. So it means 6 times. But also I will do this trickle or single row actions and multi-row actions. Trickle delete, multi-row delete for customers, for orders. So altogether, I will have 12 different procedures. And I will do some rows, row by row delete. And then I will have a procedure to do some some set base delete with some predicate multi-row, and then also in orders, and batch delete in orders, and batch delete in customers. Since I have a foreign key, I have to delete orders first, then I can delete customers. Trickle update, it's not problematic. I'm not updating key columns, so I can do it in any order. But again, I'm doing trickle update for orders, trickle update for customers, and then batch update for orders, batch update for customers. The same thing for insert. So altogether, I have 12 different procedures. Okay. Now, then I go again with these tables for results. I don't know if I created them anyway. I will not even run this. I have actually even to change the event session. So I'm now in different database. I'm not in AdventureWorks. So if I want really to measure it, I have to delete the previous session and recreate it with new database ID. This is something that I would like to see that would be parameterized database ID, that I could use dbid function to get the current database ID. And then I'm warning the cache, starting the session, similarly like previous demos, writing CPU times, starting CPU times, reads, writes, logs, and then running these 12 procedures. And in each procedure, I am measuring also the elapsed time. So I have detailed results for elapsed time. And then I do summary statistics update, stop the session, and harvest the results. I don't know where I am, probably. Oh, I didn't delete. These are the results from the previous measures. Fortunately, I didn't delete them. I will show results in the Power BI report. Just let me now show the code for different ways of following the changes or finding the delta. So for triggers, I create archive tables for orders and customers, and then I simply create simple triggers here after insert, update, delete, where I actually insert whatever I have in inserted and deleted tables. Okay, and then I go to measure the performance, and here from this part there is no change in the code. So the only change that was done was adding triggers and of course creating archive tables. And then I use the same procedures for all of these actions. And then I update the statistics and we will see the result. What is the impact of triggers? We know that we already have the result from a previous session. But before that, let me show you the code for the output clause. Now let me go to my folder and look at this sizes of the files. Look at testing T-SQL performance 3_2. This is with trigger 7 kilobytes. First one is 13.3.1, but here is where I also made the infrastructure. Look at the file 3.4, it's 8 kilobytes. This is one for temporal table, but in between 3.3 is 15 kilobytes. What is this one? Let me open this one. So this one is, of course, for the output clause. So this one is the output clause. I'm using same archive tables as I used for triggers, right? But then I actually didn't even bother to create the procedures for this part because I cannot use the same procedures. I have completely to change every single statement to include output into. So you see, so I will use output into to archive orders that were deleted with trickle delete. And then the same thing for customers. And the same thing for batch delete, right? Again, I'm not using even dynamic SQL here. I have to add output close to every single delete statement. And then I have to add output close to every single output update statement. And of course, to every single insert. And that's why this file is so much longer. And of course, what does it tell you? That output clause is practically useless. Here it's finished all of the actions, and then I update the statistics. So output clause is practically useless on existing applications. I mean, who will go there in applications and update or change every single insert, update, delete, merge statement to include the output clause? It would make sense only if we would get a lot of improvement in performance compared to triggers, or maybe if we just if we don't have to permissions to create triggers, but we can change the code for maybe one or two or couple of these data modification language statements. Now let's check like summary results. Of course, it's good to be in the right database from my previous measures, right? And this is the last one I already started, you see, and didn't finish. That's why I have negative values. Fortunately, I will not refresh the data in my Power BI report. But look at these numbers. Let's say like CPU time. Output is leading. Reads, output is leading. So let me go to my Power BI report and let's see. CPU time, temporal tables are the best. Compared to none, of course, is if you do not write anything to archive, it's the most, the best performance, of course, the most efficient way. But the bad thing or negative surprise is that output clause is, in terms of CPU times, slower than triggers. What about, let's say, elapsed time? Again, output clause is slower than triggers. Triggers and temporal tables are practically aligned. What about reads? Reads are here not so important. Of course, none means the least amount of reads, but still temporal tables need less reads from these inserted, deleted tables that they are using triggers and output clause row versioning in TempDB. So temporal must read maybe from original table. So still less efficient, more efficient writes. Let's click writes. And again, output, not big differences, but again, output is the least efficient. And what about logs? Well, output less efficient than triggers. So let me summarize here. What I found, you see, when you start measuring things, then you can really realize few things. So for example, for me, output clause is dead. Is dead. I mean, come on. I expected that it would be more efficient than triggers, and it's more like inside the statement. I don't know how it is implemented, but still trigger is better. Temporal tables are very efficient. This is also one thing that we should learn. So don't be afraid to use them. And I use this default. So temporal tables also use page compression. So it's somehow connected with previous demo. Output clause maybe only, like as I said, with this exception could be useful, that you need to follow one or two statements and you cannot add triggers to the table. You cannot create, let's say, temporal tables. Maybe you don't have any alter permission in current database, but then you can create archive tables in your own database and then use output clause. So this is practically the only scenario I can imagine why I would use output clause. But what is important here is this, that when you start measuring things, you can really get some results that were not expected. Think of it, what did we get? I decided to measure compression, GUIDs, and this finding or storing the change data somewhere, different methods. So I used this infrastructure to measure this, and I already got some surprises. I knew that GUIDs are inefficient, but I had no idea how bad they are for database performance. I really didn't have any idea. I remember a time, it was, I don't know, at least 15 years ago, when I did some optimization of some database that used GUIDs for every table. First thing we did, fortunately, we had enough time overnight to rebuild or reorganize all indices. There were GUIDs practically everywhere. And once per day was already giving us, like, I don't know, 5 times better performance. But then practically this is what you can do. You cannot do much more. And you saw that the impact on performance is like 25 or even up to 100 times compared to not using GUIDs compared to compression. Also, another not so dramatical result, but still surprising result. I didn't know that output clause is so inefficient. So as I said, for me, after these measures, this output clause is practically dead. So, okay, we are coming to the end of time. We have some time for chat. Let me check if there are any questions in chat. Okay. So first question, maybe ChatGPT can shorten the code ever tried. Let me make a little bit more longer comment here. ChatGPT and artificial intelligence is extremely useful for these procedural languages, which are using lower level of abstraction. SQL languages are on a higher level of abstraction. And here is where most of this, you can always write much better code manually. There are so many examples. So, you know, this artificial intelligence is learning from web, so it's always learning for traditional solutions. So, for example, you will practically never see that AI would use apply operator, which can be extremely efficient in SQL Server in many occasions. Or maybe you can use some mathematical knowledge, any kind of knowledge to write more efficient queries. And let me go. Deepti, we have still a couple of minutes, right?
Technically, we are for 1 hour. We are just 3 minutes over, so you can just answer the questions. That's fine.
Okay. So I will not show, but I have a couple of examples of queries that no ChatGPT or Copilot or Grok can make better. They always make the same story, and you can make better by yourself. So considering anything on higher level of abstraction, everything that is more logical than physical, we are still better than AI, at least some of us, let's say like this. But I use, for example, Copilot in RStudio. I cannot even imagine writing R code without Copilot anymore. It's really extremely efficient how quickly you can write a lot of code if you know what you are doing. But for Transact SQL, no, I still prefer to write it manually. Okay, the next chat is actually, yeah, It's already answered by Ronen. Yes, not to shorten the code. Oh, one more thing. I don't like shortening code in general. First thing is that I want to write readable code. Readable, because even code that you wrote 6 months ago, if it's not readable already, okay, maybe since you are younger, it will take you longer. For me, when I'm older, already after 6 months, I have no clue what the code is doing if it's not written properly in a readable format. And this is the first step. The next step is I check for performance. Shorten never. Yes, and it is a joke. Yes. Okay. Then is question about GUIDs. GUIDs are suboptimal. GUIDs are suboptimal, not just with compression in general. I tested GUIDs without compression, just compared to compression. Okay, hash bytes results as var binary. Yes, I would say I didn't test this, but since, by the way, if you look at the chat in my first message, I actually sent a link to my OneDrive where you have one zip file. One person already tested it, so this zip file can be accessed. I will leave it there for a couple of days. And this zip file has PDF version of all of the slides and all of the code, all of these files. So it's a lot of Transact SQL code. So yes, you can also use hash bytes, but I don't know who is this person. Oh, Piotr P. I hope you don't mind if I also include this in my presentation. Great idea. I hope that you don't mind if I use it, since I think since I'm using also GUID already, it would be very, very good to test also with hash bytes. So if it's okay, thank you very much for this idea. And then we have Evelyn. Is this recorded? I think yes, Deepti recorded. Yes, yes, and Deepti already answered. Could we get examples? Yes, I already mentioned, and many thanks. Oh, okay. Could I reshare? Let me go back to the first message in the chat, and let me resend the message. So now it should be available. I mean, the only way how it could not work is if you have some limitations in your company, so you cannot access OneDrive, but then maybe Deepti can find another way. Maybe they have with Deepti you might have, or Ronen, you might have some repository for code. Piotr, thank you very much. Thank you very much for the permission, and thank you especially for the great idea. I mean, I will definitely, in any way, I would definitely check it, compare it to GUIDs, but it's also useful to include it in presentation. Thank you very much. So in general, it seems like we are done. So thank you everybody for joining me. I hope you enjoyed. I hope you learned something useful, and that you will also be able to use this code useful before you implement some critical decision in your system.
Thank you so much, Dejan. It's a great session.
Thank you.
Just tiny my 2 cents to this. So first of all, there is an advantage in output in one big use where you need flexibility, because output is controlled by the developer. Sometimes you don't want to use everything. Trigger is automatically used for anything that you are using. So this is one point. The second point, you said that, if I understood correctly, that you are not sure why the trigger is so better than the output. So if I will dive, we can have another session for this, but if I will dive in a very short to the internals, it's because of the way the trigger use, or better say, the way that the inserted and deleted tables are stored. They are not stored the same way a simple table is stored in the database. If you want another tip, or another test, if you want to do, I haven't done it, but I do recommend to add to those tests the option to use in-memory table for the output. I'm wondering if this will give you the same or close to the solution that you get on Trigger. So if you have time, maybe I will do it for myself. I haven't done it. I'm wondering if this will make the difference.
Let me answer to this question. Of course, we cannot show everything, but 2 days from now on Saturday, I will go to the live conference in Pordenone, Italy, and there I will also show this in-memory table. So I already have demos also for this. And to answer, yes, things are faster, but of course, especially if you use schema-only persistence, not schema and data. And I would definitely recommend them to use them in the ETL process for staging tables. But also the much bigger difference, if you compare, I compare like regular tables, TempDB tables, and these in-memory tables, right? In-memory are, of course, the fastest, but even bigger difference is between single row and batch inserts, right? This is really important. So I'm testing this in data warehousing scenario.
Yeah, so the scenario that I'm talking about is just to add another test for this session, for this lecture, to add another test of using output, but output will be to a in-memory without only schema. And then from there, you can use the data if you want, exactly like you are using inserted and deleted. And then you can actually compare this in-memory using output to the trigger, and I assume that this will give you the answer why trigger is faster than a simple table, output to a simple table. So it's we can check.
Yeah, there is, there are many additional ideas, but also one thing is I wanted to have the same environment. So then it would be also necessary to test triggers with memory optimized tables and so on.
Okay,
for
session,
tables, you cannot, for archive tables, you cannot use memory optimized tables.
Don't forget to follow the call for speaker. We are going to open it in a few days, probably for the Future Data-Driven Summit. I would like you to submit a session, a new session, bid for the event. It was a great session.
Okay, thank you very much.
Thank you everyone for joining. And yeah, if you do not have any more questions, then we will look forward to see you next week then. Thank you so much, Dejan.
Thank you. Bye.
Bye.